We know full adders are used for one bit binary addition. Okay, there is A0 and then B0 and then the carry 0, which are sent through a single full adder. Okay, which are sent through a single full adder, and that will give us the outputs S0 and then the C1. Okay, C1. Here C0 is the C in and C1 is the C out, and since we are working with the convention 0, here we will put FA0. That's it. How does this work? Well, if x is equals to A0 and y is equals to B0, and then the C in, okay, the carry in equals to C0, then the final answer x plus y plus C in will be equals to C1 is 0. Not C1 plus S0, C1 is 0. What do I mean by this? Well, let's say x is equals to 0, y is equals to 0, and Cin is equals to 1. Well, then the output will be equals to 0, 1. Why? C1 is the C out, which is equals to 0 in this case, and S0 is equals to x XOR y XOR Cin, and that is equals to 1. That's it. So this is the basic idea you have to know about full adders before you come to ripple carry adder. What are we going to study in this specific video? Well, if x was equals to 1 1 to the base 2 and y is equals to 1 1 to the base 2, now there is a problem when we are trying to find x plus y. Why is it a problem? Well, the full adder can only work with 1 bit inputs. Okay, 1 bit inputs. It can work with 3 inputs, okay, but only 1 bit inputs. Here we have 2 bit inputs. X is equals to 1 1 and y is equals to 1 1. So how can we work with this? How can we work with this? Well, it's pretty simple actually. First of all, let me do this addition for you step by step. So we have to add x and y, right? So here we have 1, 1 to the base 2 and then 1, 1 to the base 2. Okay. And now we have to add these two numbers. Okay. So this is the zeros, 2 to the power zeros place. This is the 2 to the power ones place. And this is the 2 to the power twos place. Okay. Instead of calling them 2 to the power 0, 2 to the power 1, 2 to the power 2, I'm going to say column 0, column 1, column 2. Okay. That's it. If I add this one and this one, what will I get? Well, the sum will be 0. Okay, the sum will be 0 and the carry out will be equals to 1. So that 1 will be sent to column 1. Okay, then if we add these 3 bits, we will get the sum is equals to 1 and the carry out will be equals to 1. And since here we don't have any inputs, so it will be 110 to the base 2. That's it. This is what we are doing. This is how we are adding. Okay, and we are going to translate this into full adders. That is all we are going to do. Okay, we are going to come up with a sensible solution to add all these bits. Okay, how can we do this? How can we do this? Well, you have to be very careful. Okay, here was also a carry in, which is equals to 0. The carry in was equals to 0, and column 0 contains the least significant bit. That is why the C in, this is the C in row, right? This is the C in row. And this is the X row. And this was the Y row. Okay, this is the Y row. C in row, if you consider this, the carry out of the specific column, okay, the carry out of a specific column was the carry in for the column that is ahead of it. Ahead of it. For example, the C in for column 1, C in for column 1 is equals to the C out of column 0. And it was the same with C in for column 2 was the C out of column 1. That's the only connection that we are going to make. So you do understand how this works. Okay. Now we are going to go for the full adders idea. Okay. So let's start with the column 0. Okay. Let's start with the column 0. Here, instead of calling x and y, I'm going to say A0, B0, and then the C0. What is A0? Well, A0 is the 1. Why? Because x is equals to 1, 1, and y is equals to 1, 1. The zeros place of x, okay, the column 0, the number that is in the column 0 of x is a0. So this is a0, and that is what I'm going to input. And b0 is the bit that is in the 2 to the power 0 space, or the column 0. And C0 is the C in for column 0, which is equals to, you guessed it right, 0. So B0 is equals to 1 and C0 is equals to 0. Now we are going to input all these three into a full ladder. Okay, into a full ladder. And we are going to call this the full ladder 0. We are going to call this the full ladder 0. And this is going to give us the outputs S0, S0, and then the C out. And let me name it as C out, just C out. Okay. Now, what is going to happen? Well, the S0 will be equals to 0 and C out will be equals to 1. Okay, because these are the three inputs. So the respective output will be this. Now, let's go to column 1. Okay, let's go to column 1. We will have the A1 as the input, B1 as the input. Okay, this is A1, this is A1, and this is B1. Okay, and here we have C1 as the carry in. Okay, C1 as the carry in. And we will feed it to another full ladder, which is the FA1. And it will give us S1 and the C out. Okay, C out for FA1. For FA1. Okay. Now, the important idea is the C out for FA0 is the C1. It is C1. As we learned in the addition, C in for column 1 is the C out of column 0. So the C out of FA0 for FA0 will be the C in of FA1. That's it. That's the connection that we are going to make. We are going to make a logical connection between them. Okay. So instead of saying C out for FA1, can I call this just as C1? It is okay, right? It is fine. And instead of calling this as C out for F1, can I call it as C2? It makes sense because if I am using another full ladder, FA2, C2 will be the C in. Okay, since we are calling C0 as the C in for the FA0, then C1 will be the C in for FA1, C2 will be the C in for FA2 if I'm going to use one. But we don't need one because the X and Y contains only 2 bits, then 2 full adders are enough. Okay, so A1 is equals to 1, A2, B1 is equals to also 1, but C1, which is the C in, C out from FA0, which is equals to 1. So this is equals to C1. So the S1 will be equals to 1 and C2 will also be equals to, well, 1. That's it. Now, do I need another full ladder? No, not really. Because I have the C2, I have the S1, and I have the S0. Okay, because C2 is the number that's going to come in front of the column 1, which will be the column 2, which output is 1. It should be the 1. The output 1 will be 1 because we don't have any specific inputs. So the final answer will be, if we have to add A1, A0 plus B1, B0, the output will be C2, S1, S0. We are not adding these. I'm just representing how bits are arranged. If the bits are arranged like this, the output will be arranged like this. Here, A1 is equals to 1, A0 is equals to 1, B1 is equals to 1, B0 is equals to 1. C2 is equals to 1, S1 is equals to 1, S0 is equals to 0. So this is how full ladders can be connected in a logical way to create a ripple carry adder. Ripple carry adder. Why is it called ripple carry adder? Well, each C out is sent as the C in for the next full ladder, right? So it is like a wave forming in a pond. Let's say there is a pond like this, and you are creating a disturbance in the center of the pond or somewhere in the pond, it doesn't matter. It will create a ripple, a vibration that makes ripple in the pond, in the next layer, and then to the next layer, and then to the next layer, like this, right? So here, unless the ripple touches the next layer, okay, unless the vibration touches the next layer, the ripple will not be continued, right? The ripple will not be continued. It's the same thing. Unless the C out is sent to the next FA, the full ladder as the C in, okay, C out is not sent as the C in, then the full ladder won't work. So, what do I mean by this? Well, even though it has some merits, okay, the ripple carry adder has some merits. Let's list the merits first, or the advantages first. What are the advantages of ripple carry adder? Well, they have a simple design, okay, they have a simple design, and they are easy to build. Okay, they are easy to build because the logic is very simple. Just connect C in and C out. That's it. And then it uses identical full ladders. Okay, we don't need to use anything special. Just we can use the same full ladder again and again. Okay, with the same logic. Okay, these are the advantages. But there is a disadvantage because delay increases with the number of bits. Okay, there is a delay, right? Why? Well, if C out, okay, C out or C1 is not sent to FA1, then the FA1 can't perform the function, right? The specific Boolean function, it cannot perform it. That's the problem. So as the number of bits increase, okay, as the number of bits increase, the delay will also increase. Number of bits increase, delay will also increase. That's a big problem. Okay. For this, there is a remedy. Okay, there is a remedy called carry look ahead adder. Okay, which we are not going to cover in this video. That will help us to actually remove this delay. Okay, or reduce this delay by a lot of time. Okay, so that's it. Before we finish this video, this is the summary for you. Okay, let me just say the important things. So let's say we have two operands. Okay, let's say we have two operands, and the two operands are composed of n number of bits. Okay, n number of bits. Okay, if they are composed of n number of bits, the full ladder, the ripple carry adder, which is composed of full ladders, will look something like this. Okay, so from the least significant bit, we will be starting, right? Okay, from right to left. So let me name this as A0, okay, and B0 and C0, the inputs. Okay, this is FA0 for column 0. And S0 will be given as the output for the least significant bit. And then C1 will be connected to the next full ladder, okay, which is FA1 for column 1. Okay, so here we have FA1. And here the inputs will be A1 and then B1. And the output, the sum will be S1 and then C2. And this will happen, okay, this will keep happening until we reach FA minus 1. Okay, until we reach FA minus 1. Okay, where the input will be Cin will be Cn minus 1 and the An minus 1 and then the Bn minus 1 and the output will be Sn minus 1 and finally we will have the output Cn. Okay, so the final answer will be if you have n number of bits which are arranged like this. Okay, so it starts with An minus 1, An minus 2, dot dot dot, A1, A0, and you have to add bn minus 1, bn minus 2, dot dot dot, b1 and b0. The output will be cn sn minus 1, sn minus 2, dot dot dot, s1 s0. This is how the ripple carry adder will work. Okay, so this is for the combinational circuits that we are going to cover in this course. In the next video, I will be teaching you about the differences between combinational and sequential circuits. So don't forget to watch that video also. Thank you for watching the video on how to make ripple carry adders. If you found this video helpful, don't forget to like, share and subscribe for more lessons. I'll meet you in another lesson. Until then, keep learning and stay curious. Bye bye.